Good afternoon, ladies and gentlemen. Thank you for joining this session. You could see that I was the reception man in this case, and I am the MC for today, the man that is doing the communication between this side of the room and that side of the room. And next to the MC, I'm also the MD of Pepperl+Fuchs. So you see, we guys keep busy, but I think it's all for the good cause to get you introduced in the process automation and more specifically digitalization in the process industry. Today we have two prominent speakers. We have on the one side, and that is going to start, and I'm starting with the ladies, Rob, Katlego, Setwaba. Kat is our regional sales manager in Sub-Saharan Africa for the explosion protection equipment and stuff that we are doing. And she's going to talk about what I would say the OT side of things, operational technology, and how do we bring the device to the engineer, whether that is a design or a maintenance or any type of other engineer. How do we get the transparency from the top of the communication chain in a process environment up to the field device? That's going to be her story. And then Theron, or Robert Theron to say it completely, and he's from Proconics. They are joining us today, and from what I understand, he's going to do more of the ICT side of things. And you know, digitalization in the process industry is about OT and IT are meeting each other halfway to make things happen, because doing the operational technology, handling the transmitters, the devices, the actuators out there is very instrumentation oriented, but nowadays it connects somewhere, somehow to an IT system, and therefore we need the IT guys also to collaborate in that environment. So in that respect, and now she's taking over, so I'm going to fill up the time until she's ready to start. I'm going to show you a few slides, and this is not a commercial story, this is a technology story that we are going to do, but allow me to do two slides on the commercial side of things. But before we continue, if you are also looking for your CPD accreditation of today's session, then make sure that you have filled in the participation list. And for those that have it in their bags, there is also a questionnaire that you need to fill in. Please hand that in on the table again, and then we will share that information with EXA, that is in collaboration with the SAIMC, our Society of Automation, Instrumentation, Mechatronics, and Computer Engineering. That's a mouthful. Having said that, a few words on Pepperl+Fuchs. We are a German company started in 1958 to be precise, by Walter Pepperl and Ludwig Fuchs. Today we are 6,450 employees, going up and down a little bit nowadays around the world. We are located in every industrialized country around the world, and we are still today a family-owned business, third generation, and we are looking forward on keeping it like that. And you can see that about 600 engineers are constantly developing products, technologies for the future, and that means that we also try to keep at the forefront of technology when it comes to our type of business. And our type of business is, and do we have a laser here? Yeah, we do. But it's not showing too bright. So on the top left side, you see an overview of our sensors. If I put that in a process automation context, you will find them back on your valves as valve positioning, but also on manholes and other things where you need to detect the open-close status. We do also a very big program on explosion protection products to interface between the field and the DCS, ESD, fire and gas system, and whatever the higher system is. And today you will see that that system is actually becoming a PC. And we do even tablets and phones for the explosive hazardous area. And for those that are working a lot at Sasol, they will obviously know what that is about. And then last but not least, over here, you see a lot of companies, part of our company, that are providing products also that are complementary to our offering, but I'm not going to go too much into detail. Today it's about digitalization in the process industry, and this is where I stop and Kat should be starting. There you are. I was looking for you. Thank you.
Thank you, Marc. Okay. I'll be on this side of the room. Good afternoon, everyone. I think Marc has already introduced what we're going to be talking about today. But before we get into the technology itself, the motivation to go digital, why do we want to do it? If you think about what digitalization offers us, it offers us efficiency, it offers us quality because we have much more data that we're able to get from the field, and we have better speeds. And with all of that, the aim is to also reduce costs of our installations in the process plants. So today, the technology that we are going to be talking about really does reduce risk because we work in the process industry, and now that we're in Secunda, we are dealing with hazardous environments as well where we need EX. And so with that, let's look at the history of the process industry as we've had it and the technologies we've had. I hear that there were pneumatic systems, but I don't think that was back in my days. Sorry, the mic is too high. Apparently in the 1950s, they were pneumatic systems. I think I was too young enough to have encountered them in my life, but some of you in the room who have a bit more experience than I do might have seen them. And we started then having 4 to 20 milliamp, and by the 1980s, we started having 4 to 20 milliamp with hot. I hope those that are in instrumentation, these are terms that are very familiar with you. And in the 1990s, late 1990s, we had the development of field bus, and today we have Ethernet. So with time, over the past years, 4 to 20 is a technology that everybody knows. If there's something wrong, you take a multimeter, you go and measure, you're like, okay, this is what is wrong, and you're able to easily do diagnostics, so they say, right? And what field bus and the field bus systems and HART over time wanted to do is to give us that accessibility to the field and the diagnostics that we wanted to have in the field. But with it came a few challenges. Vendors had their own gateways, their own licenses that didn't make it very interoperable. I don't like this English word because I always struggle to pronounce it, but I hope you understand what I mean, that things did not really talk to each other as they needed to. And so users found it very hard to handle. And so the complexity increased with time, although the technology was aiming to get better. And with time, users ended up going from using field bus systems and going back to using 4 to 20 because they think it's simple, I can get what I need when I need it, so why go the fancy things but apparently if something works, don't change it, right? That's what people like saying. So what does Ethernet then, the capabilities it gives us are? We know today Ethernet, all of us are familiar with it. At home, we have digital homes, most of us. We have things interconnected. So it's a protocol that we're all used to, right? And with the technology we're going to be talking about today, you will really see how easy it is to handle. As you can see, this was decreasing, and now we aim to increase that handling complexity with Ethernet because it's a protocol that a lot of us are already very familiar with. And we're also trying to increase the acceptance to really go beyond using 4 to 20. There's not enough that we're getting in terms of data by using HART. There's a lot more capabilities that our field devices can give us, and we are not getting to use that data as we should. A lot of people know now that apparently data is the new oil. So why are we not harnessing the data that we really already have in the field to make our lives simpler, to increase our quality and efficiency, and ultimately reduce cost? So Ethernet APL itself, as I mentioned, is a technology that is trying to look at all those. What happened was that all those challenges the user groups looked at and said, what are the challenges that we are having today from a user perspective? And how can we create a technology that can be employed in the process industry? I think the important thing to remember today is that we are dealing with the process industry where we have hazardous environments, EX environments, and so forth, and very harsh conditions as well. How can we create a technology that will then correct all those issues that made it difficult for people to move away from analog technology to digital technology? So today, as we have it, the process plants, my laser pointer, forgive me, it's being absorbed by this whiteness. But as we have it today, from a control going up, we are already using Ethernet. And like I said, it's a technology that we're already familiar with, but in the process environment, we still haven't deployed it down here. And what are the challenges that has made it difficult for us to deploy it that we aim to change with Ethernet APL? Firstly, in our process industries, we are dealing with two-wire cabling. You know, with 4020, you know, with field bus or from Profibus PA, that we are dealing with two-wire cabling. So with that, we need Ethernet and we need comms and we need loop powering of our devices. We also need very long cable lengths. If some of you who work with Cecil know that some of the cable lengths are very long. And we also need something that is easy to handle because we've moved away from field bus for a reason, and need also technology that is harsh, that is robust enough for our harsh conditions. And so with Ethernet APL, ladies and gents, I can say that all those questions or worries have been corrected. So today, this is the Ethernet cable that most people know and think of when I say Ethernet. But with Ethernet APL, we will be using the same two-wire cabling. For those that want to see the technology, by the way, in use, we do have a booth on the inside where we are showing a demonstration, a live demonstration for you to see exactly what I'm talking about here. So it's a two-wire cabling that is the same as what is being used today in the process industry. It's familiar, it's known by the artisans, so that usability or handling complexity that people claimed to have has been taken away from. And then with that, we also have very long cable lengths. I'll get into the topology later, but from a field switch, as you see here, which we'll get into a bit later, I hope the people at the back can see, but if you can't, I'll show a better slide later. From the field switch itself, from the field, you can run an Ethernet cable up to 1,000 meters, which is quite long, and I think works for a lot of the process industry, well, most all of them. And then from the field switch itself to the field device, the spur lengths there are 200 meters, which we didn't have even in foundation field bus or in Profibus PA, because the spur lengths there were 120 meters. We also have speed. We need speed. Speed is king for some people. Some people say, rather. And for our process industries, we also need explosion protection. In this case, intrinsic safety. But more than anything, we also need power over these to be able to power our loop-powered devices that we use in the industry. So we looked at 4 challenges, and what does that show us? That Ethernet APL as a technology can really be a technology we can adopt for digitalization to be able to have more information, more data, as we said, better quality, efficiency, and so forth, but still made for the process industries that we're working in today. So literally, I think when you saw the ad for this talk, it said, bringing the plant to the engineer, and that's literally what it does for us. We are able to see everything as though they are right in front of us. And if you do come to the booth, I'll be able to show you some live demos. And maybe for those that have been to the booth, it will now make sense now that we've gone through some of these topics. The other important thing that was done when the standard itself or the technology itself was done was that people complained that devices aren't, that word that I don't like, interoperability, that they're not interoperable. I always stumble on that. And so it was made from the creation of the technology standardization, the people who made the standard made sure that all the challenges are addressed. And so with the conformance testing, all vendors are manufacturing to the standard, and there's no other way for you to be able to manufacture unless according to the standard. Otherwise, then it wouldn't be an Ethernet APL device. So these were some of the protocol associations that came together to address the different topics that are needed in a process plant. I won't go into each single one of them, but maybe some of them are familiar to you. But in essence, the point was to make sure that we are forming one single form of physical layer testing, and we're all testing to the same way, and we are all following the same requirements to make sure that there is true interoperability. After this presentation, I think I'll be good at saying that word. And so when we look at a plant topology, an example of a plant topology, for those who couldn't see at the back, what Ethernet APL also offers us is to be able to virtually have any kind of plant topology, whether you want ring, trunk, and spur, whatever it is that your current plant is at today, we are able to adopt Ethernet APL, not we, because anyone that manufactures to it, Ethernet APL enables that capability. But the other good thing that this gives you is that if you already have today a plant where you have an installation, be it on Profibus PA or on Foundation Field Bus, and you want to do a new installation, a brownfield installation, you can keep your current topology as it is and be able to add that onto the Ethernet backbone. We'll get into that slide a bit later, but it's quite important for me to mention that about topologies because the technology doesn't make you change the topology you have. You can keep what you have today because of its ability to be able to have any sort of topology. You are then able to easily add brownfields to your installations. Oh, the cable length I was speaking of earlier there. Right. And then the other thing that was an outcome of the standard is to have a true engineering guideline that will help you as an engineer when you're designing a plant to know exactly what to do in terms of switches, cabling, field devices, and so forth. And with that way, reducing risk, simplifying design, and accelerating deployment. And the part about accelerating deployment and really how easy it is to integrate the system, if you do come to the booth, I'll be able to show you just how easily you can add a field device to a network. Thank you, ladies, for coming. We work in an EX environment where it's important for everything to be certified. So we are able to offer solutions in certified enclosures with your field switch, as you see there that, I hope you can see my very faint laser, with the cables running into the field. So as you can see that this is field mounted. And we have power, surge protection, and even a fiber optic splice box because you'll be running a fiber optic cable for your Ethernet all in one enclosure. So those are some of the things that we are able to do to make installation in the hazardous areas using Ethernet APL easier for the user. We are able to also offer that in stainless steel. And remember I mentioned earlier that today you have a plant that already exists that might be using 4 to 20 milliamps, might be using Foundation Field Bus and Profibus PA, and you want to add Ethernet APL, and you would like to have every instrument that you have today onto the Ethernet backbone. So what we're able to do is that if you have 4 to 20, as an example, there's a system we have called Remote I/O. As you can see, my faint laser. I'm trying. As you can see there, the RJ45 connection there, you're able to then add your legacy signals, be it a 420, be it if it's a sensor and it's just a digital, you're able to add all of that onto this one backplane and have Ethernet out. And then still have your installation of Ethernet APL. What does this do for you? It means that with the plant infrastructure that you have today, or rather installation that you have today, you are able to future-proof your plant and have the access and data that you require for all the other things we spoke of earlier, even though you're not ready to move over your entire plant to Ethernet APL. And what our solutions also mean is that we are also able to offer you turnkey solutions for EX environments to be able to really have Ethernet in the field. This is the first time we've been able to do this because all the other Ethernet based protocols that exist today do not have the capabilities for process industries as we're speaking of today, especially on the EX side, especially on the cable length side, and so, oopsie, sorry. With this being Ethernet-based, or all these being Ethernet-based, what does that mean? That we are able to really access this from the cloud, and with any device that is also having access to internet, you can now really see and view your plant at glance. When you're, let's assume you want to do maintenance and you want to have a look at an instrument that you're looking in front of, and you know the exact serial number. With a phone and tablet, and that's why there's the next slide there, we have EX phones and tablets in our range that you're able to really do the visualization that you need in the hazardous environment, and also maintenance that you need to do. This picture shows there that this guy is watching something being filled there, and so the capabilities that we're able to offer, which are beyond what I've shown today, but with the little time I have, is to show that really we can move our plants forward and in the process industry and start really employing digitalization, be it by using Ethernet APL as a technology from on the physical layer side, or even the visualization that we are able to use with what we are used to today, like everyone in the room has a phone and a tablet, and be able to do that same sort of work that we do in non-hazardous areas in hazardous areas. With that little talk, I'm going to hand over now to our ICT side to see how we then integrate OT with ICT. Thanks, Robert.
Thank you. Thank you, Kat. Wow, that was loud. Setting the bar high. Thank you very much, Marc and Kat, for making Proconics part of your presentation. And I think this is a very good fit in what we're trying to the message we're trying to get across. So this concept of bringing the plant to the engineer. So I'm head of the Proconics Advanced Solution Department, and I'm pretty sure I have the best job in the world. So they actually pay me to play with drones and toys, and I'm paid to find better solutions and better ways to do engineering. So within the Advanced Solution Department, we have something called UAS, Unmanned Aerial Systems, and we use these drones to capture information within the plant. So this can either be done by photogrammetry, so taking photos of an object. It can be done via LiDAR. It can be done via thermal cameras. And then something that we've recently started doing is called acoustic imaging. So it's sort of a camera, but using microphones. So you can search for anomalies within the plant. So looking at how engineering has evolved and how we currently do things at Proconics is, if you look on the left-hand side, it's an isometric drawing. So most of the mechanical engineers will immediately recognize it. But looking at that drawing, it's very tough to visualize. It's very tough to see what you are looking at. You see a bunch of lines and you see a bunch of numbers. So if you're not a mechanical engineer, that doesn't really mean much to you. Now, looking on the right-hand side, let me see if you're, this one here, you'll see that it's in 3D and it's colorized, it's gamified. It's something much easier to understand. It's something much easier to visualize. And this is very helpful if you're teaching young engineers as well, as you can show them what it actually looks like in the plant without physically exposing them. The top right corner looks like a photograph, and unfortunately I can't do a live demo now, but that is not a photograph. That is a 3D model that you can manipulate in real time, and you can see the top and the bottom of the pipes. You can do measurements in it, and like I'll show a little bit later on, you can mix it with VR and with augmented reality, where you can physically walk around in between those lines, so seeing what it's really in the plant. And then the picture just to the left of that, in the top here, it looks very strange, but that was a very big achievement. So everybody knows about terrestrial scanning, where you do LiDAR scanning from a fixed position. And then, but the problem with that is you can only see the equipment from the point of view of the terrestrial scanner, right? So you get a very you get a picture that's very hard to visualize. So we found a way that we can mix drone scannings and terrestrial scanning with each other and still achieve below 3 millimeter accuracy. So that's quite impressive for those that know how that works. And then you get a picture like that where you're actually able to see the inside of the line. You can see all of the area around the line, all of the area around the plant, and I'll show some more examples around that. So 3D mapping and modeling is done with the drones, like I'm showing you there, but it also allows you to do inspections of areas that are typically not very visible. So you can see the right-hand side where the drone is flying next to a power line, and doing inspections on top of a power line is traditionally done using helicopters. That's the only way that you can do that. But it's dangerous for one, and it's very expensive, and new drones are able to do that very cheaply. Then if you look at the 3D modeling side of the things, looking at a cooling tower at the left-hand bottom here, and then zooming into the anomalies within the cooling tower. So traditionally, this would have been done with a lot of scaffolding that you had to build around this cooling tower. And using this technology, you're able to build very accurate 3D models and visualizations of what the true situation is like. So a good example of this would be the flare that you see on the right-hand side. You can't really get very close to it with a drone because of the heat. But if you look at the photo that was taken from the drone and how we zoomed in to a specific JB that is against that flare, it is no longer necessary. So when, for example, you have a flare startup and you want to make sure that all of your pilot lights have lit, we can take off with the drone, we can do a complete inspection of the flare while it's in operation, no shutdown needed, no cool down needed, no scaffolding needed. So this has really changed the way that we collect data. Right, so another couple of examples, as I said, with the flare tips, if you wanted to see whether your pilot lights are lit. So this is an example of the flare that was taken at Astron in Cape Town, and they were not sure that all of their pilots were actually working, and the only way to really visualize this was by using our drone and then taking some photos with the thermal camera. These are examples of plant models that were taken. So this was also flown with a drone using our LiDAR camera. And this is an example of what I spoke about earlier, where you are able to do terrestrial scanning in between these hard-to-see places where the drone cannot see. And then you mix this into a digital twin of your plant environment. So another great tool that we found around using the drone technology was around progress monitoring. So, and the next slide I'll show you some examples around this as well. Same with that, using a technology called SLAM. So SLAM is simultaneous localization and I can't remember the M. Simultaneous localization and measurement. So it is a way where you walk around with a LiDAR scanner and you don't have to have it fixed in one position. So instead of taking a scan, walking a couple of meters on, taking another scan, you're now able to just walk with the scanner. And that means that you can attach this thing to your hard hat potentially. And when you're doing a site walk, you can create a 3D model of the object you're looking at. So a good example is that orange. It's a part of a mining, continuous trackless mining system. And that 3D model was taken by just walking around it. There was no actual LiDAR scanning being done there. And then obviously, once you have these devices scanned, you can do things like finite element analysis, and then something that gets me very, this is also more 3D models, and something that gets me very excited then is the actual application of them, which we'll get to now. So this is what I just explained around the SLAM, the simultaneous localization and mapping. And if you look at the top right corner, you'll see what we call a dollhouse effect. So this was a substation that we walked through, and we created a digital model of the substation. And the best way to explain it to people is sort of like Google Maps. You're able to walk around, you're able to mark specific locations, you can attach documents to it. And if you look at the right-hand side, you can see an example of where you're walking through the substation, but you're also able to measure. Because even though it looks like just a 360-degree video that you're taking while you're walking, it is also LiDAR scanned, which means that you can do very, very accurate measurements within these 3D environments. So you can see here in a project, this is on the top of the electrical cabinet, and we were able to measure the difference between the top of the cabinet and the HVAC ducting. And this is the reason why we put this on here, is to keep us humble, because this is a project we messed up. We built these cabinets and we didn't use the scanning. And when the cabinets arrived, there was no space to install them in the plant. And then we realized, okay, well, we have the technology in-house. We went in, we scanned it, and we were able to send to the manufacturer the exact dimensions that these cabinets have to be. So this is one of the examples around, and what Kat mentioned earlier as well, is bringing the plant to the engineer. If you have this scanned model, you're able to do the design in-house. You don't need to take additional people to the plant. You don't have to expose people to hazardous environments. From the safety of the office, they're able to do this engineering with very accurate information. So another very good use case of where this was used. So this is a 100-meter high gas separation column. And on the left-hand side, it was drone scanned and modeled. In the center, we used AI with a company called Layer. They're a scaffolding company. So we used an AI program where we designed the scaffolding for this 100-meter high column. And then on the right-hand side, you'll see where it was actually built in the plant. So what's great about this is this broke a record, a world record. This is the highest once-off structure built with scaffolding, and it was only built in 5 weeks. So this is extremely quick. Typically, a structure like that takes around 12 weeks to set up with traditional scaffolding, and then you cannot build all of the floors at once. It's sort of like they can only build 8 platforms, and then they need to break it down. It takes 4 or 5 days for them to break down and move the platforms up and then make it safe again to work on. Where in this case, the scaffolding was built within 5 weeks, and it remained like that until the shutdown finished. So they're guessing that around 100 days of man hours were saved just by using advanced technologies within the design. Right, and then progress monitoring. So this is something we use our drones quite extensively with in Proconics. So construction sites, I wanted to show you a project we're currently doing in the R, but I wasn't allowed to. But I'll explain the concept of it is by doing daily flights, we map the entire area, both in 2D and in 3D. And then you have the slider where you can slide and you can see the progress as it progresses through the project. So think about it as you build a building, you will see the building coming up from the ground as it's being built. And what's great about this is we overlay our designs over it. So all of our design drawings get overlaid and you can immediately see conformance to the design. But what's also great is progress monitoring and progress reporting back to your client. So showing your client what is really happening there. And in the R project case, our client is in Joburg, but the construction site is in the R. So they really appreciate this because they don't need to continuously send people down to the R. We have a pilot station there, and he does daily progress flights for us. All right, and then lastly, using those maps, we also do gas dispersion modeling. So what this is in essence, you take about 10 to 20 years worth of weather information in that area, and then we simulate up to about 1 billion points at a time of gas being dispersed, being leaked. So leakages within the plant, and then we simulate where those leakages would typically go, taking, say, up to 20 years of weather information into account. So what does this do? What does this allow us to do? Well, one is it allows you to find the most appropriate spots to put gas detector equipment. And then the other thing is, once there is a release of gas and you have an evacuation alarm, how do you know that you're not running towards the area where, oh, you shouldn't run, one. How do you know that you're not evacuating towards the area where this gas cloud is going to move towards? So what makes this great is you can do predictive analysis, taking the current weather at that moment into account and the composition of whatever the gas is that's being leaked. And you could potentially close muster points. So you can have a light at a muster point that's either red or green. And if you see a red light at a muster point, you know you must use an alternative point. So a lot of really good safety information into that. And then also for firefighting. So if they have this information and they know where this gas cloud is moving towards and how it would typically disperse, you can better prepare to fight should a fire break out because of the gas release. Right, so then just, sorry, I'm going as quick as I can, Kat. So like a real teenager, I always roll my eyes if people tell me about Industry 4.0 and AI and the latest buzzwords in the industry. But just a quick story about how AI saved my life. And it's about this. About a year ago, I had a massive heart attack, very unexpected. I don't have heart condition or anything. But the device that saved my life was my watch, my smartwatch. So Galaxy recently launched something called Galaxy AI. And the smartwatch started to warn me, to tell me that my heart is skipping beats more and more and more. And I always thought like, okay, it's not tight enough around my arm, or, typically technology stuff not working as intended, and I ignored it. And on a flight from Europe back to South Africa, I had a heart attack on the flight. They went to hospital, they were trying to figure out what was wrong with me. And when the doctor saw I had a smartwatch, he asked me, can they draw all of the data? Can they get all of the medical data? And I said, sure. They looked through it, and they came to me and they gave me my diagnosis. So I have something called sudden death syndrome, or it's stage 2 heart block is what they essentially call it. So the communication between my brain and my heart doesn't work anymore. So I need a pacemaker, which I have now. But had I believed what my watch told me and went to the doctor, it could have potentially have been a lot less worse. So I look at Industry 4.0 and AI, the buzzwords, now in a different light. I think it's something that's busy changing our lives. So how does this affect us in South Africa? And looking at the current heat map of AI use, what is our biggest challenge in South Africa? It's energy, right? Power and energy. And if you look at the AI adoption heat map of South Africa, we have it in health, in climate action, in agriculture, but we have very low adoption within energy, which is surprising. And I really believe that we as engineers and we as the future of this country have a big role to play in that. So obviously there's a lot of pros in using AI, and I'm not going to go through all of them, but some of our biggest challenges is around the skills shortages that we have, regulatory and ethical challenges, and workforce displacement. So combining AI with our everyday lives and starting to incorporate this into the way we gather information, the way we bring the plant to the engineer, I think we can make a difference in this. And if anybody would like to chat with me afterwards around this, I'm very passionate about the development of young people in our country and how to make this part of engineering. A lot of people are afraid that it's going to displace our work, and it's going to take work away from us. But if we, I don't know if you guys know Charlie and the Chocolate Factory. Very similar to that, Charlie's dad lost his job because they got an automation machine that fills up the toothpaste. But someone had to maintain that automation machine eventually, and Charlie's dad upskilled himself and got him into, got back his job and basically maintaining the machine that displaced him out of it. So, yeah, I guess my message is don't be afraid of it. Good. So mixing AI and what you've seen so far into one, what do we get? So you can get some very interesting effects, and this is an example, and I might have to do it from your computer, Kat, but this is a project that we did a little while ago using PNF's Ecom tablets because they wanted to use this within the plant. And I'm just going to play the video here, something exciting to see. But imagine the possibilities of this in the future. So sorry about it being on its side, but this is looking at a plot plan, and you can see the plot plan popping out of the paper in 3D, and you're able to manipulate it. And this was done using a mix of our drone technologies and 3D modeling, and then a bit of AI magic. So that's clicking on one of the points of interest, and you're able to see everything around you from the point of view of the drone at that moment. So for training purposes, this is a very powerful tool. And that's it. Thank you very much.
Thank you, Rob. Shall we call that a presentation with a heartbeat or multiple heartbeats? I'm happy that you were able to do that. Nice job. Ladies and gents, we are coming to the end of the presentations, and I think you can agree with me that we saw a very broad spectrum today of what digitalization in the process industry means. And this was only a glimpse. There is much more, but in the limited time that we had available, we tried to give you a bit of a taste, and hopefully we created the need for more. But before you go, are there any questions that you would like to ask one of the speakers or an experience that you want to share with the audience? Let me give you the microphone so everybody can hear your question.
Thank you. Sorry, that last video, that's where my question is. Would that be real time, or you can, like, you're doing that from footage that you shot and like stored it or have it on hard drive and stuff like that?
Yes, so a combination. For that example, the requirement was to develop a training program for that road loading area. And that training program included virtual reality, so actually walking around within that area. That was done with the same model, so you're able to walk around and look around what it looks like. But the idea around that was that the students had the tablet with them within an EX environment. So that was, we basically modeled the entire area, captured all of the information, modeled it, and then put it on the tablet. But it can be real time. So we're working on a proof of concept project for a client of ours now, where during their last shutdown, 7 live lines were cut incorrectly. So they had to cut lines, and they unfortunately cut live lines instead of the lines they were supposed to cut. So we're looking currently at a project where we have this information and you use augmented reality type glasses, because you already have safety glasses on it. So you have a little augmented reality screen in front of you, and then once you look at the line and you're in the area, it'll highlight the line. It'll tell you this is the one you're supposed to cut based on your permit to work. So once you register your permit to work, you register the glasses that this is the line that we're going to work on, and in the plant, it'll highlight it for you.
Thank you. And the tablets that he's talking about are these ones, and they are made for harsh environments. Any other question, ladies and gents?
So restrictions or regulation regarding flying the drones over places, pilot license or something like that?
Okay, so it is very strongly regulated in South Africa. I think we can commend the Civil Aviation Authority for doing that. But for example, it's much easier to fly a drone in the US than it is in South Africa. But yes, you need registered pilots. But not only that, the company that does the flying has a whole host of accreditation that they need to have. So there's post holders, and they run it very similar to an actual aircraft company. So you have post holders within the company, and then you get rated according to what your skill level is and how sophisticated your setup is within your company. So they look at things like how do you handle safety, how do you handle quality, and if you consider that engineering companies then make very good drone operators because safety is baked into what we do and how we do it. So yes, you have to be rated to be able to fly over a national key point. You have to have night rating if you want to fly at night. There's a concept called BVLOS, beyond visual line of sight. So if you're not rated for BVLOS and the drone flies behind a vessel, for example, it's not legal. You have to have it in your line of sight. But we are rated for BVLOS up to 5 kilometers. So the drone can be 5 kilometers away from the pilot, and we are still allowed to operate. So yes, there's quite a big list of requirements before you're able to fly a drone legally in South Africa. These drones are also very heavy. I mean, at the M300, the big drone that I showed on the picture there is about 30 kilograms. So imagine that drone flying at almost 200 kilometers an hour hitting you. It would be bad.
Thank you. We have a question over there.
Thank you. Good afternoon, everyone. Mr. Roberts, I just heard from your presentation, you mentioned something that you're very passionate in terms of grooming young people of some sort. So I would just love to hear from you that you guys have any maybe programs or skills development that you offer to groom young people of today, like how if a 2000 want to actually venture into engineering. And when we, the 90s and the 80s, most of, when it comes to engineering, we were more based on the hard labor. And now we can see that you can move into, it's technologically advanced. So yeah, what are the tips that you can give some of us as parents here that as steps that we can take in terms of growing our kids into the AI industry?
MD, MC.
Thank you, Marc. Yes, so there's many programs around. I'm hoping, I don't know how much of it I can share yet, but I'll give you an example of one program. So Eskom has a program called the Expo for Young Scientists. That's a brilliant program if your kids are still at school. A very good idea to get involved, but also I want to invite engineers as well to mentor these kids. These kids need help. So, for example, I'm mentoring 2 children at the moment where I'm teaching them how to manage a project. Because you learn the skill at school around math and about science, but you don't learn how do you communicate? How do you do stakeholder involvement? How do you manage a project or a schedule? And those are skills you typically learn only when you get to the work environment. But imagine having the skill already at a school level and then going into, it puts you that level above. The other thing is a lot of the engineering companies in this area have these kinds of programs, ma'am. So I'll give you an example. If we do a big construction project that's not close to one of our offices, we always take local community youngsters and we make them good drone pilots. So we put them through an entire process of how to get their license. We actually take them through that process with the CAA. And I don't think there are many other drone companies that actually do this at this stage. So we give them a lot of exposure. We train them how to use these drones. And by the time the project is finished, we use them within our project, obviously. And by the time the project is finished, they have a skill that they can make money with. We supply them with some of the cheaper type drones, but that's a perfect drone to use, for example, for weddings or for get-togethers or for nature or for capturing imagery around the area where they live. And apart from that, that's now specifically the drone one. With engineering as well, we do have internal programs, and you're welcome to contact me afterwards, and I can give you more information around how that works. And we have something very exciting coming up, and I'm hoping that the SAIMC and PNF will be part of it. I had a very brief conversation with them, so hopefully we can do this collaboratively. But yes, it's important that the engineering community prepare our future engineers. We believe we want to solve South Africa's energy problems using South African talent, and I believe we can do that.
That's a very good statement that I can only support. And by the way, I'm the chairman of the board of the SAIMC, and I only can support what you just said. As a non-South African, and you can hear that from my accent, I think this country has a lot of capabilities and future available, and we need to make it happen, but we need to make it happen ourselves. Let's not bring in Chinese, Indians, or whatever, and not that I have anything against those, but it's like Rob said, the local people need to do it. And as the SAIMC now talking about our organization, we are also focusing quite a lot on the development of young people, getting them introduced with digital technologies in the broadest sense of the word. And by the way, Marita is from Proconics is already involved in those discussions as well, so it can only get better. Any other thing that you want to address before I let you go? And for those that want your CPD points, don't forget to hand in your questionnaire also that you found in your bag or on the table over there. We will do the administrative work, get that to EXA, and then you get your CPD points accredited via the normal process. I don't have a clue what that is, but you will figure it out. Thank you so much for being there on behalf of Proconics, on behalf of Pepperl+Fuchs. May I wish you a joyful day further on. The sunshine is quite nice, but the temperatures are dropping quite quickly, so go out there and enjoy. Thank you.